Okay, so our next presentation is about weather and climate. And part of what I have to do is to distinguish between the two. Okay? So let's take a look at that. So weather relates to what's happening in a given day and time. So today we have moderate conditions. It's not super cold. It's not raining right now. But from, if you listen to the weather report, it might say something like, well, we're going to have torrential rain on Wednesday night into Thursday, okay? Which is the actual weather report at this point. So the weather deals with what is happening at a given point in time. And climate is very different than that in that it's the general temperature, relative humidity, insolation, and a number of different things for a given region. Okay? So the climate of Palm Springs is very different than the climate of Newport Beach, right? But both Palm Springs and Newport Beach can see temperatures in the 50s. Both Palm Springs and Newport Beach can see rain. So understand that when we talk about the weather, it's what's happening now and on a daily basis. Climate deals with a much broader thing. It deals with the general characteristics of a region. Okay? So hopefully that makes sense. To be more specific, weather is the state of the atmosphere at a given point in time or day. And we just talked about how we can have very different air temperatures and very different relative humidities between two particular cities. So an example, Southern California can have a winter day with a high temperature of 53 degrees and a low of 39, accompanied by cloudy skies, rain, thunderstorms, strong winds blowing out of the southwest. Okay? A very different scenario than that, okay, can occur when we have Santa Ana wind conditions, right? You guys have all lived in Southern California enough to have experienced a warm Santa Ana. And so you could be in the middle of June, okay, and you can have a day that is bright and sunny, that has a daytime high of 86 degrees in January, in the middle of winter, and has an overnight low of 56 degrees. Now that sounds like summer to me, or spring. But see, that stuff is occurring in winter time. And it's an anomaly. That's not what temperatures are typically like in winter. So, all right, continuing on. So climate is the average weather usually taken over a 30-year time period. Okay? So they average out the past 30 years for a particular region. Okay? The climate is going to be the average pattern of weather throughout the seasons for that particular region. One of the sites that you'll be using, that we'll be looking at probably later today, is called weatherspark.com. And it has all sorts of useful little charts to kind of understand the climate of a region. Okay? When we look at the differences in climate from a global scale, we start to see that, hey, things are kind of different in different parts of the world. Okay? And so when you look at this particular chart, you see that there are tropical regions, there are what they call mesothermal, which is a mild winter, there's desert areas, there's polar, microthermal, and highland. So this is one way of sort of classifying what the global climates might be. Okay? And notice that they vary significantly depending on where you're at. Like if you take a look at the United States up there, you'll see that there's a portion in the northeast that's cold, right? It's microthermal. So there's a section down beneath that that's mesothermal, which is it's more temperate. And then you start to look that you kind of start going across, and there's desert areas, there are highland areas, which is going to be the Rocky Mountains and the Sierra Nevada. That's those gray ones in the middle there. So there's a lot of different climate zones and regions across the world. When we start to look at the USDA zone map for plants and stuff, which deals with the climate of a region, you're going to see that there's a lot more of them, okay? And that now we're looking at the United States at a different level of detail than we were in the previous slide. So if we go back to the previous slide, right, according to that, the United States only has 4 climate zones. But when you look at this one, it's got a lot more. And that's because we're looking at it through a different lens, okay? If we step in even closer and we look at California itself, California, the state of California has developed 16 different climate zones within California. All right? And you can see that there's notable differences within an area that if we went back 2 slides, right, was kind of all the same. It's all this green area right there. And if we go to the USDA zone map, it looks like, well, there's, maybe 4. But then we get to California's zones, looking at it more specifically, and it's got these 16 zones, okay? So it just depends on what level of sort of inspection you're doing, what level you're studying it at. So I mentioned earlier the B-52 song, Rock Lobster, right? Girls in bikinis, boys on surfboards. So this is an example of those days that we talked about a little bit ago. And these are days that happen pretty regularly here in California. So we can have a Santa Ana wind day, okay? And that Santa Ana wind day, the high temperature up in the Big Bear Mountain area might be 63 degrees, okay? These are both occurring on the same exact day. So daytime high, 63. Overnight low, below freezing. That's how they make snow, okay? On the other hand, if you're down in Newport Beach or Huntington Beach or Seal Beach or somewhere, right? The same exact day, you can have a high air temperature of 85 and you can have an overnight low of 58. Now in California, this happens through a process called compressional heating. We've talked about it once before, right? The continental portion of the United States is not at sea level, okay? So the area on the other side of the San Gabriel Mountains and the Sierra Nevada is on a high plateau. If you go out to Victorville or Hesperia, your base elevation is probably 2,000 feet, maybe 2,500 feet of elevation, whereas if you're in Newport Beach, you're at 0, or pretty close to 0. So what happens when we get a certain condition where we're taking the air mass from the continent, and instead of what it normally does, which is blow towards the east, a condition sets up where it blows west. So now it goes up over the mountains, and then it comes way down. And as it comes down, it has more and more and more atmosphere above it, which means it squeezes the air together, and the air gets hotter. Okay? So again, this is sort of highlighting. There's another song up there, On a Winter's Day. That's the Mamas and the Papas. You guys, no clue. Never mind. Huh?
California Dreaming.
That's correct. California Dreaming. All right. So factors that are going to define a climate are going to be the seasonal variation. How much and how extreme. Right? What is winter like compared to summer? The temperature, and when we say temperature, we mean the dry bulb temperature. And so, one region is going to have, temperatures that fit within a range. In a different region, it's going to have very different temperatures. And those, in turn, are going to relate to the seasonal variation. Humidity. There are some regions that get a lot of humidity. Other regions don't get a whole lot of humidity. The amount of rainfall, the amount of cloud cover. Right? Cloud cover is essentially a way of blocking out solar insolation, the amount of solar energy received. The amount of sunshine is the opposite of cloud cover, and wind direction and velocity. Those are the common things that make up climate, or the climate of a region. Okay? So some of the factors, the global factors that could influence the climate of a region are going to be, how far north or south of the equator is it? Do you guys think it's cold at the equator? No, it's not. It's not cold at the equator at all. All right? I mean, maybe if you're at a really high elevation. So, for example, Hawaii, I believe, is lower in latitude than us, and you could go to the top of Haleakala and experience very, very cold temperatures. But that's because you're up in elevation. Which brings us to the second thing, elevation. Okay? So how far above sea level are you? The further you get up, the closer you are to outer space, let's call it, right, the colder it gets. All right? Proximity to large bodies of water is, I don't know, is Kansas City, Missouri close to any oceans? Not really. It's in the middle of the country, right? Is Los Angeles close to a large body of water? Oh, that large body of water is the Pacific Ocean. And you could say that Miami is close to a body of water, right? It's close to the Atlantic and the Gulf of Mexico. The next thing that's really important in considering the proximity to a large body of water is what's the water temperature like? Well, the water temperature in the North Pacific, the region that hits us, is cold. Our water doesn't typically get very warm. Even in El Nino years, it only gets relatively warm. Okay? But if you go to Florida or you go to the Keys, right, the Gulf of Mexico is almost always warm. Okay? So, and then the next thing is the position of an area within a landmass. Okay? So it's proximity to the oceans, but also how much land is around it. So as I mentioned, something in the middle of the country, Albuquerque, New Mexico, right? It's really far away and it has a lot of land around it. So typically, those types of places are going to be affected by what's called the continental air mass. So I don't want to go over on anything, so I'm going to stop this here.